What is the universe made of? The dark truth about reality. When we look up at the night sky, whether it's with our naked eyes or through the lens of a telescope, what we observe seems endless. Galaxies stretching across the void, stars shimmering in distant corners of the cosmos, and nebulae glowing like cosmic brushstrokes on a black canvas. It feels natural to assume that what we see, these stars, planets, gas clouds, and galaxies, is all there is. But astonishingly, modern science has revealed that the visible universe, the part we can actually detect and measure using light or electromagnetic radiation, is just a tiny fraction of what truly exists. In fact, all of this, everything we've ever seen or touched, accounts for less than 5% of the entire universe. The vast majority of the cosmos is made up of something we cannot see, cannot touch, and do not fully understand. This realization has led scientists to confront one of the most profound questions in all of physics and astronomy. What is the universe actually made of? To answer that, let's start with the small slice of the universe we do understand, what is called ordinary matter or baryonic matter. This includes everything composed of atoms, which are made up of protons, neutrons, and electrons. It is the substance of all life and everything we interact with daily, from the air we breathe to the blood in our veins, from the earth beneath us to the distant stars that burn with nuclear fire. It is also the basis of everything we've studied in chemistry, biology, and classical physics. However, as we began to study the large-scale structure of the universe, particularly through observations of galaxies and galaxy clusters, we started to realize something puzzling. The gravitational effects we observed in these massive systems couldn't be explained by visible matter alone. Galaxies were rotating so quickly that, according to Newtonian physics, their outer stars should have been flung into intergalactic space. But they weren't. They held together, as if held in place by some invisible mass that exerted gravity but emitted no light. This invisible substance was eventually named dark matter. Dark matter does not interact with light or other forms of electromagnetic radiation, which makes it invisible and incredibly difficult to study directly. But its existence can be inferred from several key observations. One of the most compelling is the way it affects the rotation of galaxies. If only visible matter were present, stars on the edges of galaxies would orbit more slowly than those near the center. Instead, we find that they orbit at roughly the same speed, suggesting the presence of a hidden halo of mass surrounding the galaxy. Another important clue comes from gravitational lensing, the bending of light around massive objects, predicted by Einstein's theory of general relativity. In many cases, we see light from distant galaxies being bent far more than it should be, given the amount of visible matter nearby. The additional bending implies the presence of unseen mass, dark matter. Furthermore, the large-scale structure of the universe, the vast web of galaxy clusters and filaments stretching across billions of light-years, fits models that include dark matter far better than those that do not. Although we have compelling indirect evidence for dark matter, we still don't know what it is made of. It doesn't consist of regular atoms or particles we're familiar with. Scientists have proposed several possibilities, such as WIMPs, weakly interacting massive particles, or axions, hypothetical particles that could make up this missing mass. Experiments around the world, including those in deep underground detectors and high-energy particle colliders like the Large Hadron Collider, are searching for these particles, but none have yet been found. Despite this, dark matter remains one of the most important components of the universe, making up about 26.8% of its total content. That's over 5 times more than all the visible matter combined. But the story doesn't end there. In the late 1990s, astronomers studying distant Type Ia supernovae, the explosive deaths of certain kinds of stars, made a discovery that would shake the foundations of cosmology. They expected to find that the universe's expansion was slowing down over time, due to the gravitational pull of all the matter in it. Instead, they found the opposite. The expansion of the universe wasn't slowing down, it was speeding up. This implied that some unknown force was pushing galaxies apart faster and faster over time. Scientists called this force dark energy. Dark energy is even more mysterious than dark matter. While dark matter pulls things together through gravity, dark energy appears to do the opposite. It pushes the fabric of space apart. It acts not on individual objects, but on space itself, causing it to stretch and expand. The simplest explanation is that dark energy is a property of space, a form of vacuum energy that remains constant even as space expands. This idea is linked to Einstein's cosmological constant, a term he once added to his equations to keep the universe static, only to later discard it. Ironically, this mistake may have been ahead of its time. Other theories suggest that dark energy might be caused by a new dynamic field, something like quintessence, that changes over time. But just like dark matter, dark energy has not yet been directly detected. We only know it exists because of its profound effect on the universe's expansion. Today, based on data from satellites like Planck and observations of the cosmic microwave background, the afterglow of the Big Bang, scientists estimate that dark energy makes up about 68.3% of the universe. That means the overwhelming majority of what exists is something we don't fully understand and cannot see. When you combine that with dark matter, which is about 26.8%, and ordinary matter, which is only 4.9%, you get a picture of the universe that is both deeply humbling and incredibly exciting. We are surrounded by vast realms of invisible substance and unknown forces that shape the cosmos in fundamental ways, even though we have yet to uncover their true nature. So, what is the universe made of? The most honest answer we can give is that we don't fully know. We know a little. We know about atoms and molecules, stars and galaxies, but the bulk of the cosmos remains in shadow. Yet this is not a sign of defeat for science. It's a sign of how much we've grown. Just a century ago, we thought the Milky Way was the entire universe. Now we know it's just one galaxy among trillions. And just a few decades ago, we believed we had mapped out most of what existed. Today, we know that the universe is filled with invisible matter and a dark, accelerating energy we have yet to name properly. This is the frontier of knowledge. The fact that we know how much we don't know is itself a remarkable achievement. Every mystery we uncover reveals deeper layers, and every new question pushes us to explore further. In the coming years and decades, we may finally discover what dark matter is made of, or learn how dark energy works, or even find that our understanding of gravity needs to be rewritten. Whatever the outcome, the journey itself is what defines science. It is a voyage into the unknown, guided by curiosity, reason, and the relentless human desire to understand the cosmos we inhabit. If this journey into the dark corners of the universe has sparked your curiosity, then stay with us. At the Nebula Nexus, we're just getting started. In our next episode, we'll venture into the depths of space-time and explore one of the most extreme environments known to science, black holes. Are they simply collapsed stars, or could they be cosmic gateways to other dimensions? Subscribe and join us as we continue to navigate the cosmic unknown, one question at a time.